A-level Mechanics, Dynamics, Power. Let's look at what we mean by power in mechanics. Now we take power to be a measure of the rate at which work is being done, and power is measured in watts. If power is the rate of doing work, then power is the total work done divided by the time taken. So 1 watt represents 1 joule of work being done per second. Now we call 1000 watts 1 kilowatt, kW. Let's look at an example. Example 1. A crane can lift a weight of 750 kilograms to a height of 32 meters in 1 minute. What is the power of the crane? Well, to solve this, we first need to work out the work done. Now, when lifting something against gravity, the work done is mgh. So the power is mgh divided by the time taken. In this case, m is 750, g is 9.8, and h is 32. The time taken is 60. So that works out, the power is 3,920 watts. So our answer is the power is 9.32 kilowatts. In example 2, a mining truck is pulled up a railway ramp by a cable. The truck weighs 150 kilograms and can carry a load of 300 kilograms of ore. The ramp is inclined at an angle of 28 degrees and is 80 meters long. The truck has an internal resistance to moving of 240 newtons, and the truck should go from the bottom to the top in at most 30 seconds. Calculate the power needed. Now to solve this, we should mark in the forces acting on the truck. First of all, we've got the weight. Now the truck is 150 kilograms and the ore is 300 kilograms, so the total weight is 450 kilograms or 450 G. There'll be a normal reaction which is at right angles to the track, we can call that R. There's a resistance to the motion of 240 newtons. And then there's the tension in the cable pulling the truck up, we can call that T. If we resolve up the plane, there are 3 forces we need to consider. We've got the tension up the plane, T. Now the weight of the truck and the ore is 450 kilograms, so that's 450 times 9.8, but it's only a component down the plane, and so we multiply by the cosine of the angle between the direction of the weight and the direction of the plane. So that's the cosine of 62. We've then also got a force of 240 newtons, the resistance force down the plane. So that gives us T equals 450 times 9.8 times cosine of 62 plus 240, which works out to be 2,310.369 newtons. Now the work done is the force times the distance moved, so that's T times 80. And the power is the work done per second. Now the total time is 30 seconds, so the power is the work done divided by 30. So it's T times 80 divided by 30, and that works out to be 6,160.985 watts. So our answer is the power needed is 6.16 kilowatts. In example 3, we're told a tube well is bored to bring up groundwater 17 meters below the surface to a tap 1 meter above the surface. A pump is required that can bring up water at the rate of 200 litres per minute. What power would the pump need? Well, to solve this, 200 litres of water must be raised 18 metres each minute. A litre of water weighs 1 kilogram. So 200 divided by 60 kilograms must be raised 19 metres each second. Now the work done against gravity is mgh. So the work done each second is 200 divided by 60 times 9.8 times 18, and that works out to be 588. Now that's the work done per second, so it is the power. So the answer is the power needed is 588 watts. Now another way of thinking of power is to relate it to velocity. If the force is constant and is in the direction of the distance moved, then power is force times distance divided by time. But velocity is distance divided by time, so power is equal to force times velocity. Let's have a look at an example to see how this works. A car has power of 90 kilowatts. It has a top speed of 144 kilometers per hour. When driving at top speed, what is the total resistance force on the car? Well, to solve this, power is driving force times speed. So when moving at a constant speed, the resistance is equal to the driving force. So the power is equal to the resistance times the speed. Now we know the power is 90,000 and the speed is 144 kilometers per hour. Now that is 144 times 1,000 divided by 60 times 60 meters per second. So 90,000 equals R times 40. And if we divide both sides by 40, we get R is 2,250 newtons. So the resistance is 2.25 kilonewtons. In example 5, we're told a car weighs 1,200 kilograms and has a top speed of 162 kilometers per hour. At top speed, the engine produces 27 kilowatts. In part A, we're asked, at top speed, find the resistance to the motion. Well, to solve this, draw a diagram and mark in the forces. First of all, we've got the weight of the car. It's 1,200 kilograms, so the weight is 1,200 G. Now there'll be a normal reaction, which we can call P, which will be vertical. We have a resistance R, which is horizontal. And we have a driving force D, which is horizontal. Now the power is the driving force times the speed. The power is 27,000 and the speed is 162 kilometers per hour, but we need to change that into meters per second. So we need to multiply that by 1,000 and divide by 60 times 60. And that gives us 27,000 is equal to D times 45. Now if we divide all the way through by 45, we get D is 2,700 over 45, which is equal to 600 newtons. If we resolve horizontally on the car, we get R, the resistance, is equal to D. And so we have the resistance is equal to 600 newtons. We're then told the car comes to an incline of 2 degrees. Assume the resistance and power remain the same. In part B, we're asked to find the top speed that the car can drive up the slope. Now to do this, we need to draw a diagram and mark in the forces. We've got the weight of the car, which is 1,200 G. We've got a normal reaction, which we can label as Q. We've got the resistance, which we worked out to be 600 newtons. And if we let E be the driving force, we can also draw that in. Now we have a force E up the slope, and down the slope we've got R, and we've got a component of the weight. Now the angle between the weight and the slope is 88 degrees. So if we resolve up the slope, we have E equals R plus 1,200 G cosine of 88. Now that means E is equal to 600 plus 1,200 times 9.8 times the cosine of 88. which means E is equal to 1010.42 newtons. Now the power is equal to the speed times the driving force. The power is 27,000 watts and the driving force is 1010.42 newtons. So we get V is equal to 27,000 divided by 1010.42, which works out to be 26.7216. So the speed is 26.72 meters per second. Now we need to change that into kilometers per hour, so we need to multiply by 60 times 60 and divide by 1,000. And that gives us 96.197 kilometers per hour. And so the speed is 26.72 meters per second, or 96.2 kilometers per hour.